To the incidents I've got, I will tell you lots of incidents where uh, minor things have caused and led to major accidents too, or accidents have just about been averted. There was an Airbus 320 when it was newly launched, a crash at Bangalore. Here it is, you do not have a physical control over it. It is like a joystick. It's electronically controlled, so you do not have the pressures. In fact, to make sure that you get used to the pressure, they give an artificial pressure to that. To feel the pressure, otherwise, that human interaction, human interface with the machine is lost. So the Airbus has got a system of main system, a standby, and a standby to standby. Usually you have a main and a standby. So they've got 3 sets of systems. Even then, the aircraft failed and it crashed because of the fly-by-wire controls. So the computer systems had to be upgraded so that if a pilot is making an error, it should not go out of phase. Now this aircraft, last position known, it was at a particular height and he had asked permission to avoid clouds by climbing upward, which was not given to him. The permission was not granted. But the aircraft before crashing had jumped up 6,000 feet and then it crashed. So the obvious answer was to the public and to the media was the aircraft did a vertical climb and the pilot kind of committed suicide. So it got termed in as pilot error.
According to several studies in the aviation industry, 58% of crashes happen due to the pilot error, 17% due to mechanical failures in the aircraft, 9% due to sabotages, 6% crashes due to bad weather condition, and 10% lies in other factors. As majority of these accidents are due to pilot error, the root cause of pilot mistakes range from fatigue to overconfidence. Here are a few examples. In 2006, Com Air Flight 5191 crashed, leaving 47 people dead. The pilot's mistake was he got confused between the runways. 158 people died in the crash of Air India's flight 812 because pilot was asleep. Due to overconfidence of the pilot, 48 people died in the crash of the Trans-Asia flight 222 in 2014. Green box. Just imagine a third co-pilot which learns from collective flight data of the world and is more wiser in taking appropriate decisions to prevent crashes. Green box is a series of instruments, systems, and advanced algorithms which prevents accidents using artificial intelligence and machine learning. The idea is to prevent accidents from happening through advanced machine learning instead of retrieving the information from the black box after the accident. Green box has 3 distinct parts: AFR, Assisted Flight Rules; Gaia, Collective Intelligence; HUD, Nudge Heads-Up Display. Assisted Flight Rules, AFR. Assisted Flight Rules is a new flying mode which combines visual flight rules, instrument flight rules, and other available data learning sources to make the pilot and the airplane itself situationally aware by using artificial intelligence and machine learning. Apart from the 80+ data received from the flight data recorder, the AFR also understands, analyzes, and predicts pilot behavior, bird migration paths, weather conditions and forecast, learning from previous flight experiences and collective flight experiences from Gaia at the ATC to recommend safer flying to pilots, develop better flying modeling data with the collective flight experiences from Gaia, making the pilot situationally aware using nudge display. In the AFR machine, the flight data recorder, cockpit voice recorder, and machine learning data is integrated in highly protected module which is made up of advanced composite materials. There are powerful GPU arrays to support machine learning and 2 powerful beacons and an easily identifiable box. Gaia, Collective Intelligence. The epicenter of this entire system is Gaia, which collates all the flight data, cockpit voices, and other parameters to build a robust model which is fed back to each flight. Gaia analyzes all the data to understand each parameters and its implication on the flying. This knowledge will be fed back to each flight depending on the context, such as the make of the flight, route, etc. With the help of Gaia, the agencies can build a robust flying model, inform airplane companies about the certain flaw in the design along with its scenario, make the pilot and the airplane itself much more situationally aware, reduce pilot errors. Nudge Heads-Up Display System. The pilot interfaces with Greenbox using the Nudge Heads-Up Display System. It provides positive reinforcement, minimal information, and indirect suggestions to try to achieve non-force compliance, which can influence the motives, incentives, and decision making of the pilots. Nudge display has four main sections in the interface: flight health, communication status, weather and environment, notification using nudge theory. Nudge display can be controlled by voice interactions, which help the pilot reduce his or her cognitive load. Nudge display and AFR work along with the pilot by voice interactions, notifying of lapses in the process and also helping the pilots by providing situational data, thereby reducing pilot fears, miscommunication and errors. This makes them confident to handle the situation, which could avert accidents. Creating a resilient system. Over a period of time, by using Greenbox, this system becomes self-correcting and self-sustaining, preventing human casualties. Through this system, the agency would now receive design flaws which will prove valuable information for building better next-gen aircrafts. Using the Greenbox, agencies can now monitor the activities of the pilots and provide scorecards on their performances. Greenbox thus makes our aircraft journey much more safer than ever.